There's our cue. Y'all ready? Petco, you good? Okay. This is probably in Science 9 one of my favorite topics, this big unit on chemistry, because you're going to learn the basic fundamentals of how everything is put together. We're going to start off with some review. This is section 1.2 from your textbook. If you're someone who likes to read notes later or study later or follow along, put your phone face down, please. Airplane pie, that's me being me, thank you. Words you're going to need to know eventually for your test on this unit. I stuck them here. We're going to go through these vocabulary words as we go along. And in fact, really you can go, got the notes that I gave you, following along, to this page here, chemistry. What are we going to learn? Well, we're going to learn why water flows but ice doesn't. We'll explain to you why fireworks are different colors. We can actually predict what color fireworks will be. We're going to talk about the structure of an atom. We're going to learn the very, very super cool periodic table. You know what? I need to be in this one, Mr. Duick. Haha. I was on last year's notes, which are already filled out. That would have been silly. We're going to learn the periodic table. We're going to learn why table salt is really called sodium chloride and how to name other chemical compounds. We're going to talk about why you can thaw and refreeze ice, but you can't uncook meat. Have you ever wondered that? I can make ice go from solid to liquid. I can do that. Why can't I somehow reverse a steak back to its original raw form? Some important points. Most of the topics here are going to build on stuff we've done the day before. So I did my homework rant before, but it's really important that you try and stay on top of your homework. Don't get too far behind. Okay? Even though I'm not taking marks off for being late, I'll keep you going. A lot of kids consider this to be one of the tougher units in science, but I've also had students tell me that I explain this really well. And a lot of them consider it one of the coolest. I'm in every day after school, and we now have flex blocks as well. So now we're going to go to filling in some notes. Matter. Matter. Matter is anything that has mass and volume. I heard that word back there. Yeah. I missed you too? It's because I don't like, no, there was a mistake. Honest it was. So I've just told you that matter is anything that has mass and volume. I guess I should tell you what we mean by mass and volume. So, mass is the amount of matter in a substance. Often we measure mass in grams or kilograms. Connor? Mass is actually the amount of energy stored from Einstein's E equals mc squared equation inside each atom of an element, which is a better definition, but I can't say that to them. A lot of what I'm going to teach you is technically wrong. You're going to learn most science on the level that you're learning it. Actually, there's a better explanation if you go one step down. And then once you've learned that explanation, there's an even better explanation if you go one step further down. Eventually, if you're talking about anything to do with atoms, you get into something called quantum theory, which is totally weird, totally strange. The math is heavy duty, well beyond me, and I got a math degree. So every so often, I'll go off on little segues like that. Volume is the amount of space a substance occupies. Volume is often measured in liter. What's the abbreviation? I tend to abbreviate. What's the abbreviation for liters? An L. Now, little side note for me, I'll never write a lowercase l like that, because what number does that look like? So whenever I want to show liters, I always do a cursive L. You'll just, if you ever notice, why are you suddenly doing the cursive? That's why. Tricks of the trade to keep things straight. Last year in Science 8, you learned what we call the particle model of matter, in theory. But I'm going to pretend you forgot it all, so I'm going to recover it. In Science 8, does it turn the page for you folks, I think? Yeah? You learned that all matter is made up of particles. Remember that? And I think you learned that even though it doesn't look it, If you zoom in, there is spaces between the particles. You knew the word I was going for. So although my desk, although your chair, although you look very solid, actually it's mostly empty space, it turns out, if you zoom in on the atomical. This is why I said most of what you think you know in science is wrong. You got to keep going deeper. What else did you learn? You learned that the particles are always, can anybody remember what word goes there? Yeah. Nice. So if you put your hand on your desk, even though it doesn't feel it, the particles are moving. Even though you can't, actually, you can feel it, but the way your skin detects it is in temperature. The faster the particles are moving, the hotter it will feel. That's why you burn yourself on something that's really hot. The slower they're moving, the colder it will feel. Why is that? It's because if it's cold, it wants to absorb energy, and your skin has extra energy, and so the energy is flowing from your skin to the cold object, and your brain reads that as coldness. The particles are always something to one another. Attracted. Nice. In Science 9, you learned about the three main types of matter, the three main states of matter. The first one has the characteristic that it has a definite or constant shape and volume, solid. A solid keeps its shape no matter what container you put it in, it still stays its own shape. What comes after a solid? And a liquid keeps a definite volume, but it will fill the bottom of a container, so it has what we call an indefinite or variable shape. It will take on the shape of the bottom of its container. But if you have 3 liters, no matter how big or small a container you put those 3 liters of liquid in, it still stays 3 liters of liquid. What's the next one? And gas has both an indefinite shape and an indefinite volume. By the way, those 3 there would make kind of a nice multiple choice-ish sort of question. You can kind of think about how I might phrase that. So if you have a gas and you put it in a container, it will always take the shape of the container and fill up the whole container. So if you have, and I'm not going to use a measurement, this much gas and you put it inside the room, this much gas will slowly spread out through the whole room. Put your pencils down, look up. Solid, liquid, gas. Are there any other states of matter? So did your teacher talk about plasma at all last year? Because that's one a lot of people forget about. There are, and by the way, there are also some really, really weird ones when you get close to 0 degrees Kelvin, to absolute zero, and some of the weird stuff going on in the sun under high pressure. But yeah, another very common one is plasma. It's a good question. Juan asked, is it impossible to get absolute 0 temperature? Yes and no. We can get in the lab really, really, really close to absolute 0. Okay? Really close, like several hundredths of a degree. However, that temperature that we're measuring is an average, which means some of those atoms, some of those particles are probably a little bit hotter, but some of them are probably a little bit lower and right bang on absolute 0. So can we get there so that we can say without a doubt that that entire big substance is absolute 0? No. But when we're doing that, could I almost guarantee that some of those particles probably are a bit lower than the average temperature that we're measuring? Yeah, which means probably some of them are. It's a complicated answer. You asked actually a far deeper question than you realize. Whoa, I was deep. Yeah. Sun is made of plasma. Stars are made of plasma. Does anybody know how to make plasma in their microwave? Nick? If you microwave grapes, I kid you not, you'll get plasma sparks. Ask me before you do it, and I'll give you better, safer instructions than that, but if you want to try. There are other cool states as well, but most of these only occur in labs under very extreme conditions or in the guts of a star or things that are not everyday. Next page. For me, a chemical change is a change in matter that occurs when substances combine to form new substances. When you blow something up, that's a chemical change. When you bake, that's a chemical change. You're going to talk about this in more detail later on this year, and especially in Science 10, but we're going to get to that in more detail. So in Science 8, you also learn what we call kinetic molecular theory. I think I've told you I tend to abbreviate, yes? So can you put in brackets KMT? I'm going to probably use that from now on. What's the K stand for? So kinetic energy is the energy of motion. If an object is moving, it has kinetic energy. And the fact that all the particles in every solid, in every liquid, and in every gas are always moving, unless they're at absolute zero, Juan, means they have kinetic energy. KMT, the kinetic molecular theory, explains what happens to matter when the kinetic energy of particles changes. So here's what it says. This is kind of what you summarized last year. I stole this from the Science 8 textbook. You may remember this, so we'll see if we can fill this in from memory. All matter is made up of very small, looking for the letter P. Okay, so particles again. Some of this I've already said. There's empty blank between particles. These particles are constantly, I'm looking forward, sorry? Nice. Now, in a solid, particles are so tightly packed together that they can't move around freely. All they can do is, I'm looking for a word that begins with the letter vibrate. Nice. You guys know your stuff. I'm impressed. Last time I did this, it was like pulling teeth. Volume, vapor, victory, velocity. They have very blank kinetic energy. Think what word goes there? Little, low, small. Let's go little. That works. When you add heat, what you're really doing is you're causing the particles to vibrate a little faster, and eventually they vibrate fast enough that they break their crystal lattice and they move freely. So in a liquid, particles are blank apart. Farther. Farther or further? I'm going to go with further because in my brain that sounds better, but it could be farther. And they can slide past each other. They have more kinetic energy. In a gas, particles are very far apart, relatively speaking, and they move around very fast. They have even more kinetic energy, and so they can completely freely slide past each other without even bumping into it. So, in summary, the blank kinetic energy the particles have, the faster they can move. The more kinetic energy the particles have, the faster they can move and the farther apart that they can get. What's the easiest way to add or change kinetic energy? Add or remove heat. There are other ways, but heating something up is the easiest way. So, if energy is put into a substance, if you're heating something up, it's going to change from a what to a what to a what? Capital S, capital L, capital G. Oh, and if you keep adding lots of heat, capital P, plasma. but we're not going to include that. Because what moves faster? Particles move faster. And the distance between the particles increases. And because the distance increases, the force of attraction between the particles, since they're further apart, decreases. Long-distance relationships don't work. If energy is removed, the reverse is true. So if you have your textbook, one per table or both of you, can you open your textbook to page 20 to see an example? For me, page 20. Okay. Here is a lovely picture. This is looking at the changes of state in gold. Clearly, that's an experiment we can't afford to do because it's gold. But solid gold, the particles are close together. We're adding heat. Now we have melting gold. Adding more heat, now we have liquid gold, and you can see now it's filling the shape of the bottom of the container. And you can actually boil gold and turn gold into a gas. Takes a fair bit of heat, but you can. It doesn't happen very often because, you know, you don't want to lose the gold. Okay. What if you boil it in like a? You would probably lose some to evaporation to the air. I'm spitballing here because I actually don't know. I imagine it could be dangerous. You probably don't want to inadvertently inhale gold vapor because it would solidify in you very quickly, which is not a good thing probably. This is page, I think, 21 in your textbook, yes? So here is a chart. I'm going to give you this chart, but I'm going to blank out all 6 of the words. This is going to be on your test, and I'm going to ask you to fill them in. So let's just kind of go through talking about this right now so we can see what the heck it is. I wrote here, you should know all the terms that describe the changes of states in matter. You can expect a question like this on chapter and unit tests. Note that freezing point and melting point are the same. Evaporation point and deposition point are the same. All the temperatures for each are the same. Some of these words, Cleo, you know. I know what melting means. I think most of you do. And I can figure out what solidification means because what's the first part of the word? Got that, going from a liquid to a solid. I know what evaporation means. I know that when water evaporates, it vanishes. No, it turns to a gas. So I already got this one under my belt. Condensation. I know what that word means. Condensation, that's what you get, for example, when you breathe with your breath onto a cold window. When you do, you're seeing the water vapor coming out of your lungs cool and turn into a liquid. Sublimation and deposition are the tricky ones. Now, deposition has the word deposit, which means, in my mind, to put something down. I have to remember that it's when a gas turns into a solid. Sublimation is when a solid turns into a gas. When it's really cold, ice can evaporate. That's what happens to your ice trays in your freezer. That's why ice trays slowly shrink over time. The ice cubes in the ice trays shrink over time. They've been sublimating. So I kind of have tried to give you some ways to keep this straight. Can you look at the reading check on page 21? And your job is, you guys are going to kind of do this as a group of 3, so one of you is going to ask it of 2 people, but you're going to decide who's reading and who's asking. Turn to your neighbor, and you're going to take turns, or you can do one question at a time, alternating, asking your partner the questions. The person being asked must not only answer the question, they must convince the questioner that they are correct. In other words, they can't no or yes, they have to say, and because, why? So, and if the questioner thinks the answer is wrong, they must correct it. So this is the reading check. It is right here. You got 7 questions. I'm going to pause and give you a couple of minutes. Back to our notes. I wrote here videos, and I have no idea what I was getting at. I think I might have had a cool, nerdy video. I'll try and find it for next class. Describing matter. This class ends at 35? Yeah. Okay. We're going to pause here. Your homework is the 4 assignments and the safety crossword. But first, I have a cool video to show you. This is something you can try at home.